part. We'll transition at this point to our next speaker, Dr. Jordon Wade. Dr. Wade came to the University of Missouri from University of Illinois, where he was doing a postdoc, joined the University of Missouri this summer as a new soil health faculty member, a new position for the university. We're also pleased that he's providing leadership of the university's Soil Health Assessment Center, which he'll be telling you quite a bit about, but I want to acknowledge as one of the very few university centers specializing in soil health testing. So we're excited to hear, Jordon, your remarks, and when you're ready, you can go ahead and share your screen. And you'll need to unmute too, Jordon.
Fantastic. You got me now?
Yes, got your
Well, thanks so much for the
And we need your slides too.
Yeah, I'll bring it up. Don't worry.
Okay.
Thanks so much for the intro, and I appreciate this opportunity here. So I wanted to kind of give a quick overview here today of how we quantify soil health, where we are and where we're headed, and of course, as director of the Soil Health Assessment Center, SHAC here, how SHAC is going to be a key player in that. So first off, I wanted to just kind of start off with soil health, this 10,000 foot view here. Everyone kind of has different ways and approaches towards soil health. And so I figured it'd be good to just get us all on the same page. So first off, we start with some sort of management. Obviously today we are spotlighting cover crops. And we're doing that, we're trying to implement cover crops because we want to have some sort of outcome. We talk about things like weed suppression, productivity, decreased erosion, those types of things. We implement a management because we want to have some sort of outcome. Now, of course, there's no one size fits all because there's so many kind of intervening and mediating factors that kind of come into play. So things like climate, where are you, how much rain do you get, and how hot is it there? Things like geology, how much slopes you got, and what kind of the bedrock is beneath your field, how long you've had a management in place, and things like soil texture. So to kind of bridge that divide between management and some sort of outcome, we use soil health assessment. And so the soil health assessment is kind of the intermediary there. The way that I've heard Rick Haney talk about it is soil health assessment is supposed to give farmers the courage to implement some sort of management and make sure that they're getting that outcome that they're interested in. Now, of course, making that link between management and assessment, making sure that we're assessing the right things is an entire mission unto itself. So when we talk about management, there's lots of different soil health principles. So of course, keep the soil covered, which is, cover crops fall very readily into that. Minimize disturbance, that would be things like reduce tillage, keep plants growing throughout the year. Now, of course, cover crops again, diversify plants, cover crops again, and incorporate livestock. Now, those kind of soil health principles have some sort of change in our soil, and it could be in different characteristics of the soil, whether it be a physical thing like aggregation or tilth, your biological activity, or decreases or changes in your chemical properties. Now, all of those things kind of come together, and those are our conception of soil health. So this brings me to the first take home that I would like for everyone here, which is that soil health indicators are not an end to themselves. As I kind of already mentioned, soil health indicators are the bridge between management and making sure that you're getting the outcome that you're interested in. Now, they are just the means. I guess that's the thing that I'm looking to say here. Soil health indicators are the means to translating management to the ends. Now, this doesn't always show up when folks are talking about it, because sometimes they will say, we performed X, Y, or Z good management, and our indicators went up. Therefore, this indicator represents soil health. So they're saying this indicator captures the change in soil health from management. But then sometimes other people will say, hey, when these indicators go up with this change in management, that means this management is good. Now, unfortunately, we can't have it both ways. And so that's why it's really important to link those indicators, that assessment, to some sort of actual outcome. Now, that linkage is a little tricky, and so it's really important to be careful with that interpretation there. And there's a lot of different ways that people can link that assessment to some outcome of interest. Now, that journey, if you will, is very convoluted, as I'm trying to illustrate here. There's lots of pitfalls, there's lots of obstacles, and unexpected things can kind of get in the way here as you are moving from assessment to outcome. Usually we use a soil health score to bridge that. But I want to start with a cautionary tale of how this can kind of go wrong, this interpretation. So the conventional wisdom is that if you build soil organic matter or soil carbon, that it will, of course, lead to greater productivity. Now, there are some folks who actually investigated this, and they started to look at it in two different ways. So first, they brought together studies from around the globe, and they kind of put them together looking at organic matter and nitrogen fertilizer application rates. And what they found is that, this is a little messy, but if you can squint with me, they see that there is kind of a leveling off around about 2% soil organic carbon. So basically, once you get over that threshold, you shouldn't reliably expect increases in productivity. But that's not really the best indicator, right? There's lots of complicating factors on this global level. So what they did is they actually directly manipulated soil organic matter, and they saw what productivity looks like. And they have other kind of mediating variables like the amount of nitrogen added and also irrigation, making sure that there's no water stress. And similarly, what they found is they found that productivity peaks round about 2%. So there's a good kind of supporting of what they found on that global level. So this is both correlative, and then here they think that this is more causation here. So similarly, we should take this caution with us when we interpret these common soil health indicators. I want to talk a little bit now about just a couple of these specific measurements. So first, I want to talk about permanganate oxidizable carbon. Some people call this active carbon. Some people incorrectly say this is microbial food, and it's incorrect. And I will kind of discuss that here in this study. But what permanganate oxidizable carbon does is we take the soil and we do this pretty quick oxidation with permanganate. And so this is supposed to approximate some sort of microbial activity. Another one is mineralizable carbon, or respiration after rewetting. And so what this is we measure the amount of CO2 that comes off of the soil after we re-wet it. Microbes, just like us, will breathe out CO2 when they are working hard. And so this is a pretty important measurement for measuring the microbial activity in your soil. Now, you may have heard of this. This is a key component of the Haney Soil Health Test. There's also a Solvita test that some people use. To be clear, this is not an endorsement of Solvita or even the Haney test. This is just to say there are multiple ways of looking and measuring soil health that use this approach. So how do we bring those two measurements together to guide management, right? To kind of start moving towards an outcome of interest. Well, this was some work that I did during my master's, and it's we had 76 sites spread across 10 different states, and we had about 1,100 different individual observations that we looked at. And at each of these sites, we were looking at specifically paired managements. So, one half of the field has one management and one has another. So for example, we did till versus no-till. We looked at annual versus perennial systems, organically managed versus conventional versus kind of transitional systems. And then of course, winter cover crops versus winter fallow, and variations in kind of rotation, things like continuous corn versus corn soy versus corn soy wheat. And what we found when we measured these, this permanganate oxidizable carbon and the mineralizable carbon, we found a consistent relationship. It happened in 100% of our sites. Now, this relationship is that when we graph these two things versus one another, we put them in the same graph, those managements that were stabilizing organic matter tended to have greater values of permanganate oxidizable carbon. So things like adding compost or no-till, et cetera, or perennial systems, these types of things ended up having more permanganate oxidizable carbon relative to the mineralizable carbon, relative to that respiration. And so what we found is that it's because this permanganate oxidizable carbon is actually representative of greater stabilization or building of organic matter, whereas that respiration, that mineralization, is indicative of nutrient release. Now, where you might desire organic matter building, right, if you're trying to combat things like erosion, but maybe some people are trying to, just decrease N rates. And so that would be, you're more interested in this nutrient release. So we can use these two indicators to say, hey, which way are you heading? Soil carbon takes a little while to respond, and this can give us a leading indication of the direction that you're heading. Now, importantly, this is something that is usable by you on your farm, anyone who's managing any sort of ground. You can go out and you can try something new on one half of the field and see, hey, which direction is this going to take me in 3-5 years, et cetera. So for example, if you go out and you put cover crops on one half of the field and leave the other half as is, no cover crops, you'll go out and you can see for your field, what will cover crops result in? Will they give you more stabilization, or are they going to give you greater nutrient release? So, this is importantly something that you can go and try and get an early indication. Now, of course, we want to validate this in other studies. And so there's been some more on-farm work recently up in Wisconsin and Minnesota, and they had a same approach. They had these paired managements, till, no-till, manure, differences in drainage and slope, rotational complexity, and cover crops, things like that. So this was on 50 working farms up in Wisconsin and Minnesota. And they similarly found a pretty comparable result. Now, these graphs don't show it very well for various reasons. They don't, I wouldn't have presented this data this way, but when they actually run the numbers, they found the same thing as our previous work, which is that the permanganate oxidizable carbon is less related to productivity, whereas the mineralizable carbon is more related to productivity on these working farms. So, of course, this doesn't necessarily answer the question about what happens about variations within a site, right? You might be targeting one part of your farm, you might have a trouble spot, and you want to know, hey, if I improve soil health there, am I going to get increases in productivity? Now, this is some work that Rick Haney did down in Texas, but I think it illustrates some good principles that we can use here. So what they did is they went out and they did really high intensity grid sampling on their experimental farm. So they sampled every 35 meters now on this grid. And what they were looking to do is they were looking to link the soil health score, specifically the Haney soil health score, to productivity. Now, on that site, they have 4 or 5 different soil types, as you can see. And so they're sampling kind of across these different soil types. Now, what they found was first that yield varied pretty significantly within that field. And you can see here that those differences in yield corresponded pretty well to a soil type, right? This soil type here and this one here look a little better yielding than this big red area here. Now, when they look at the soil health scores, similarly, you can see that this area has lower soil health scores, whereas this soil type here and this one here tend to have slightly higher soil health scores. Now, when they put those things together and they throw them together in this big graph, they find there's a generally positive relationship between them. Higher soil health values lead to higher corn yields, is what they are showing here. But when they kind of split it out by these different soil types, you can start to see that some of them are positive, like this here and this purple here. Some are kind of no relationship, like this green one. It's kind of an even slope. And then this soil type even has a negative relationship between soil health and yield. So I think that this is a good kind of reminder of an old saying, and it might be familiar to many of you, which is that correlation is not causation. Just because you have a good correlation doesn't mean that that is the cause of your increase or decrease in productivity. And one example that I like to use here is the relationship between per capita consumption of cheese in the US and the number of people who died by becoming tangled in their bed sheets. Now, of course, it's absurd to say that these two things are linked, but the correlation between them is about 95% or 0.95. So they're closely correlated, but obviously one is not causing the other. Luckily for those of us who eat cheese, we shouldn't expect it to cause us to become tangled in our bed sheets and die. So I, for one, am very thankful for that. But this correlation is not causation also applies to soil health scores, as it does for these tragic bedsheet deaths. And that's because the actual question that scientists would like to answer and have not sufficiently answered yet is, if you personally go out and improve soil health on your field, you want to know, will productivity increase? Should you expect that bump in productivity from increased soil health? So this is something that I've been working on, and we wanted to know if within a site, if you improve soil health, will you expect an increase in productivity? So this was something, it was across much of the Eastern Corn Belt, and so mainly rain-fed corn systems, and we were interested in increases in soil health and talking about nitrogen fertilization. So again, we got this wide range of soil health building practices. Of course, cover crops are a pretty important one. Tillage, rotational complexity, and again, manuring. And so we had 30 sites spread across 5 states, and each of these had manipulations to management, which would give us changes in soil health, right? So this is a direct manipulation within a specific site of soil health, and layered on top of that are nitrogen fertilization rates. Now, this was a combination of research farms that have been in place for a little while and on-farm work. And we got a really broad range of representative sites in this study. So, but before we could really definitively test this link, we had to confront a couple problems that are ubiquitous within soil health measurement here. So now the first one is, of course, every field is different. And intuitively, everyone knows this, but it doesn't stop people from lumping these things together, which, going back to that previous work, says that, you know, we can't necessarily lump all the time. We need to be really careful about that. Now, there's a couple different ways that people like to deal with this. So the first one is they just throw all of these observations together and they say, hey, does increased soil health increase yield? Now, what this does is it kind of overestimates your soil health effect, right? Because what can happen is within a field, so say like this green field here, or this red color-coded field or this purple color-coded field, you see that there are kind of differentiations within each of these fields. They don't let us definitively link soil health to productivity. Now, the other way that people kind of deal with this is they just average it across a site. So they don't account for variations within a site, and they just say, hey, on average, if this field is healthier, will I expect greater yield? And what this does is this underestimates the effect of soil health. So to kind of split that difference, what we did is within each of these fields, whether it be a green field, the red field, a blue field, etc., we said, let's grade them all fairly, and let's let them start at a different point here. And within each site, when we increase soil health, would we expect an increase in yield? That's the real question here. Now, of course, not every field starts at the same level of soil health, right? Soil types are different, and they have different changes in management history. So this kind of brings us to our second obstacle that we really had to confront here, which is how can we measure soil health in a way that's fair? Now, what we usually have done conventionally is that we go out and we measure lots of different variables, and then we kind of, to somewhat arbitrarily, combine those, and we say, hey, these things measure soil health, and we decide that this measurement is more important than this one, and we weight them accordingly. But the problem is that soil health is not something that we can go out and directly measure. We have these measurements, and we somewhat arbitrarily, again, define that soil health score. But if we can kind of flip the script here and instead approach soil health as something that we should go out and try and discover, it lets us compare across fields a little bit more fairly. So the really thing that we're trying to get at here is, what is nature telling us, not deciding what nature and what your field should look like. So this is an approach called latent variable analysis. And what it does is it really flips the arrows here, if you will, and it says soil health is out there, it's something that's underlying, and we need to use these measurements to approximate that without deciding which measurement is more or less important. So then we need to, combine all of these things into an actual testable model. So what we did is we controlled for variations in rain or precipitation at each site, differences in texture, and average temperature at each site. So what this does is it really lets us compare within a site, isolate for the effect of soil health, and also integrate it with our understanding of nitrogen fertilization and your pre-plant soil nitrogen levels. And so we are able to then measure the consistency of the effect of soil health. Again, we are really taking away all of these confounding variables to make sure that the effect of soil health is what we think it is. So with all of that run up, I'm sure you're wondering, is a healthy soil more productive? And the short answer is yes. To maybe add a little bit more color and nuance to that, soil health positively influences yield, and it's on the order of about a 20% increase in soil health in these soil health measurements specifically, translates to about a 5% bump in yields. Now, importantly, fertilization, nitrogen fertilization, actually increases soil health as well. That nitrogen increases the amount of microbes you've got in your soil, and they're able to then get to work for you and increase that soil health and bump your yields up. Now, for those people who are, want to know the numbers a little bit more, I'll just suffice to say that we had a really good fit between this model and the actual observations. So that gives us a lot of confidence in that. Now, this means when you are improving your management, when you have some change in management, that when we use these soil health assessments, when we go out and use these indicators, it can help us link it definitively to the outcomes. So you can go out to your field, whatever field that might be. We have these different color fields here. You can measure the health of your soil, and we can reliably say that improvements in soil health will be improving your productivity on your field. Again, we are not committing this correlation causation error. When you go out and improve the soil health of your field, you should expect an increase in yield. So the take homes, again, first, when indicators are the means to deciphering your management effects. Your specific management effects might vary, and so we want to make sure that we go out and we measure and that those differences are showing up. But that's not where we stop. We want to make sure that when we take that assessment, those soil health indicators, that we're linking it to some specific outcome. And that can get a little tricky, as you may have seen, but it's definitely not impossible. And there are ways that we can kind of tease that apart from your field specific effects. Now, this is where, I'm going to talk a little bit about the Soil Health Assessment Center, the SHAC. And this is going to be a very important part of our mission and our kind of heading moving forward. We want to make sure that we are taking whatever management you have on your field, and we're able to give you that courage, as Rick Haney says, give you the courage to make that change in management and have some expected outcome. So future work that we're going to be working on at the SHAC is figuring out new, faster, cheaper, and more robust indicators. We want to make sure that these indicators are robust over space and time. We want to make sure that you can go out to many different soil types, measure the indicator, and get a reliable assessment of changes in underlying soil health. We also want to do it in different systems. Today, we talked a lot about corn, but of course, there are other crops that are grown and, or forages, et cetera. And also, we want to make sure to do it under dynamic on-farm conditions. So this is where I will put out the call to you, which is to say that we are interested in working with you and making sure that we're doing this on-farm soil health assessment and making sure that we are testing these indicators in real-world conditions. So things like working through cover crop cost share, working with your local extension, working with NRCS, et cetera. We'll get things set up, and we can make sure that we're getting you the information that you are interested in. Next, kind of long-term vision here for the SHAC is to connect that assessment to whatever outcomes might be of interest. We want to use these soil health indicators as both diagnostic tools and also just decision support tools. Again, helping you make sure you have the courage to implement these things on your field and kind of help you sleep a little bit better at night. And of course, we want to connect it to more than just yield productivity, right? We want to think about things like resilience to low rainfall, right? Drought. We also want to think about nutrient use efficiency and also things like runoff, erosion, et cetera. And we also want to increase our certainty in that by incorporating things like seasonal weather forecasts. If it's going to be a wet year or a dry year, how does that influence how we interpret that soil health assessment? How does that influence how soil health relates to your outcome of interest? And I will also mention that this is where we are eager to work with our colleagues here on campus, and we're looking to broaden our assessment, and we're looking to integrate that with kind of the more conventional soil fertility measurements with our soil and plant testing lab here on campus. Soil health and fertility go hand in hand, and so we're really looking to collaborate with them on some of these projects. So we're really looking forward to that. And with that, I would like to just say thank you and move to any questions, comments, et cetera. And for those of you who are getting the CEUs, we've got the link right here. So thank you.
Thanks very much, Jordan. That was a great overview of some of the things that are happening in soil health measurements and the direction that's going to happen. I see we're starting to get some questions in the Q&A portion. As folks have some questions, feel free to type those into the Q&A. There's a button at the bottom of your screen or icon to allow you to do that. We have roughly about 7 minutes or so to go through some questions with Jordan. I want to just start with one myself, Jordan, and then we'll go to the ones in the Q&A. As you know, you can make some rough analogies to going to your doctor and having your human health measured. And I'm sure you'd agree there's not one single thing like cholesterol score or blood pressure or temperature that really tells the whole story of human health, right? So when you look at soil health, your lab, the Soil Health Assessment Lab, obviously offers a large number of possible tests, and there's some packages people can choose. Based on what we currently know, what are kind of your favorite 3, 4, or 5 tests for getting some indication of health, knowing it's not the complete picture of soil health?
Yeah, so if I were to choose, I'll go with 4. If I were to choose 4 soil health unique measurements, so that's outside of your traditional fertility things like pH, extractable nutrients, the 4 that I would choose are the permanganate oxidizable carbon, the mineralizable carbon. I really like ACE soil protein, which is a measure of protein in the soil. It relates to things like end supply and also things like aggregation. So it's a good integrative measure. SHAC will be offering that soon. And then my 4th is aggregate stability. So I think that those 4 things give us a lot of really good information about soil functioning. Now, of course, more measurements can be better, but I'll say for SHAC, those are the 4 that we are going to be going kind of all in on at first. Those are the high return ones for now. But we are looking to expand in the future and test out more things to get more and better information about the health of people's soils.
And I know you have additional tests available through the Soil Health Assessment Center and kind of summaries of what some of those provide, including we've got an extension publication that describes some of that for folks. So appreciate that answer. We've got several questions popping into the Q&A, so let's go ahead and get to those. The first one is, as the soil biome complexity and robustness reaches a healthy plateau, does synthetic nitrogen continue to help, nitrogen fertilizer? Yeah.
So I will say that I don't think we can ever just do away with synthetic nitrogen. I think it's a little tough. It's helpful. It's useful. It's in a plant available form. But I do think that we can decrease it as we kind of get that microbial community up and running. Now, that doesn't happen overnight. There are lots of things that play into that. In terms of measuring that soil microbiome complexity and robustness, that's a little tricky. It's so variable. And so that's a really active area of research. There are people hard at work at that as we speak. And so maybe it will reach a plateau. Maybe we can measure that plateau. Those are kind of different questions, but it's hard for me to envision doing away with nitrogen completely. Maybe there are some years where you don't have to apply. But completely doing away with it, it's hard to see that future.
So Jordan, I guess the caveat we'd want to make is if you were doing organic farming, that you would find ways to provide that nitrogen through organic sources. So.
Yeah, of course. Sorry, when I'm thinking synthetic, I'm thinking just fertilizers in general. So yeah, sure. Composts, manures, etc.
You bet. Okay, the next question is, how would you factor soil infiltration rates? So this is referring to rainfall soaking into the soil with soil infiltration rates and soil bulk density in the relationship of soil health and yield. So how would you factor those 2 characteristics in?
Yeah, I think that those, infiltration rates are going to be really important. That's an important part of soil health. How much does it influence yield? That depends on when we're talking, but I think that those are good things to consider. It's hard to measure those per se and incorporate those into our models. I think that those are kind of specifically with things like bulk density. I think of it as long as it's not so high that it's a problem. then, we should kind of be smooth sailing, and we can get some of that information contained from bulk density. The benefits of bulk density can be measured and approximated from some different measurements. So things, again, like aggregate stability, that soil protein. I think some of the benefits that come from bulk density are captured in these other measurements that are frankly easier to measure. Anyone who's gone out and taken a bulk density soil sample knows it's a lot harder than just, digging up a soil core or something. So.
Okay, we've got a couple minutes left. We'll try to get in maybe 2 more questions here. The next one is asking about a comment you made on active carbon. I think the listener heard you saying that active carbon maybe isn't a significant microbial food source, and just asking you to elaborate on that.
Yeah, I think that when we first started using that measurement they started using it in the early 2000s. I think they were kind of, for lack of a better word, flying blind. And, they said, this is what microbes eat. But I think as we've moved forward and progressed in the science, that we found that there is decreasing evidence for that. There's very little support. Yeah, I think that that's a misconception that we need to be clearing up here. And some of that data that I showed today, is part of that it is, in fact, I think a better way of interpreting it is it's carbon that microbes ate in the past tense. It is what has gone through the microbial community at least one time that they've processed a little bit. So I think that that's an important shift. It's not what they're going to eat, it's maybe what they ate. So it's a past food source.
Before we go to the next question, our conference moderator behind the scenes has put up a revised QR code. If you tried it for this session and it wasn't working on your phone, try this revised QR code. So Jordon, the next question is, could you speak to how quickly a farmer could expect to see soil health indicators respond to changes in management? So if somebody starts using cover crops, obviously some soil health indicators are going to change faster than others, but just, what would be your comment on that?
Yeah, I mean, I think it, specifically with cover crops, it depends on how good of a biomass you get there. That's kind of the signal that shows up in those soil health indicators. But I think if you get a good biomass, you can expect to see it in a year or so. If it's a little bit lower to medium, maybe it takes 2 years or so to show up in these indicators. So that would be kind of my sense. But the thing is that the benefits show up in these indicators pretty quickly. Before you